When you have a rational function and the terms reduce, like they do here, you're going to have a hole in your graph at 3. That is, your graph is not going to be defined at 3. And this is where Desmos kind of fails us. It's there, but it's not so clear to see. So for example, let's take a look at this one. I want to determine any vertical, horizontal, holes, intercepts for my graph. And then I want to graph the function and state its domain. So we're going to start here at, I'm going to first reduce my function. So it's at h of x equals x plus 2 over x minus 2. And then that's going to be all over x minus 4 and x plus 2. So notice there's a hole in my graph at -2 when x equals -2. So my graph is not defined at -2. Now I'm just going to graph my rational function x minus 2 all over x minus 4, just like I normally would, except I'm going to have a hole at -2. So I know I'm going to have a vertical asymptote at 4. I know I'm going to have a horizontal asymptote at 1. And then since we can talk about our domain then, so my domain is going to go from -infinity to -2, from -2 to 4, and from 4 to positive infinity. And we're supposed to find, yeah, let's do our intercepts. So let's find out when my y-intercept is when x is 0. So I'll get -2 over -4. I'll get 1/2. So I know I have a y-intercept here at 1/2. Let's find my x-intercept. So that would be 0 equals x minus 2. So x equals 2. You can see from that, I can kind of see from my graph what's going on here. So my graph is going to approach my horizontal asymptote at -2. And then it's going to be going up like that and over because of my vertical and horizontal. Now remember, I gotta throw in my hole. So I'm going to put a hole here at -2. So on my graph, when x is -2, it's not defined. And you'll get something like that. Now, when you do this on Desmos, the hole is there, but it doesn't show it unless you know it. So for example, let's type in our equation so you can see that.